Let's now consider the example of selecting a card from a standard deck of 52 cards. Here we have the sample space in front of us. As you can see, the deck of cards is broken down into several categories. We've got the ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, the jack, the queen, and the king. So those are all lined up in columns. We've got the four suits, clubs, spades, hearts, and diamonds in each of the rows. So we can also categorize the cards into black and red. We've got half the cards are black, half the cards are red. And we also have the face cards, right? Would be the jack, the queen, or the king. We've got a group of face cards there at the right side. And then we've got the numbers 2 through 10, which also categorize the deck of cards. So there's a number of ways to break down the deck of cards, but here let's read the first example. What is the probability that the card drawn is a king? Which we know from looking at our sample space here, there are exactly 4 kings in the whole deck. 1 king from each suit. So we'll have a 4 out of 52 probability of picking a king from the deck. What is the probability that the card drawn is a king or a queen? Well, these two events are disjoint because we see here, looking at the queens, right, there are no cards that are both a king and a queen. So this will simply just be the probability of picking a king plus the probability of picking a queen. And since they're disjoint, right, the probability of picking both of them, or picking a card that is both a king and a queen, will be 0. So we'll just simply add these two. We have 4 kings, 4 queens, and 52 cards altogether. So 8 over 52. What is the probability that a card drawn is a jack or a red? In this case, notice that there are actually cards that are both jack and red. So maybe we can highlight which of those cards here are both. Looking at the red cards, those would be all these cards here in the bottom half of the deck. So those would be all the hearts and the diamonds. And then the jacks would be these cards over here. So if I'm to use my addition rule, the probability of jack or red will be the probability of a jack plus the probability of a red minus the probability of a card that is both jack and red. Which we see there are these 2 cards that are both jack and red. So we'll have 4 jacks in the deck. We have half the cards are red, so that'll be 26 red cards in the deck. And then we have these 2 cards, the jack of hearts and the jack of diamonds, that are both red and a jack. So we'll minus 2 over 52. And that leaves us, in this case, with 28 over 52. And then part D, what is the probability that the card is an odd number or a heart? Now here again, maybe we can highlight which ones in our sample space here are an odd. So those would include these cards here, the 3s, the 5s, the 7s, the 9s. Okay. And then hearts, let's see, the hearts would be the ones here in this row here, containing all the hearts. Now, we notice that this kind of breaks down again into the sum rule, or the addition rule. So the probability of picking an odd or a heart would be the sum of the probabilities of picking an odd plus the probability of picking a heart minus the probability of a card that is both odd and heart. So looking at the deck above here, we have the hearts. There are 13 cards that are a heart. 13 out of 52 for picking a heart. There are, well, let's see, we have the odds in each column here where we've got 4 3s, 4 5s, 4 7s, and 4 9s. So I think that'll be 16 altogether. And then cards that are both odd and heart, well, we've got these 3 of hearts, 5 of hearts, 7 of hearts, and 9 of hearts. So we'll subtract 4 out of 52 for those. Now summing this all together, I think we get 13 plus 16 minus 4 will be 25 out of 52. Oops. 25. Sorry, let me fix that. Out of 52.